Oh, it's already recording. Very cool. Start video. Here we go. Camera. Here's the camera. Okay. So the question we're going to be doing is longest palindrome but concatenating two-letter words. Okay. So basically the question says you're given only two words and not only two words, an array of words which has string of words in it which are only of length two per word. Okay. So basically, let's navigate to the first question, LC, CL, GG. We want to see what is the longest palindrome we can make by adding these words together. Suppose I add LC, GG, CL. So LLCCGG, this is a palindrome. Cool. This is the question that basically wants us to do. Similarly, if you have to go to another example, say AB, TY, YT, LCCL. So basically, there's another AB. So let's just not use this AB and not use this AB. And if we use this combination, we have our longest length. Right. So palindrome, concatenating, nothing really. But what we need to focus on is this thing. Similar words, CC, LL, XX. Now output is only 2. You cannot concatenate this and expect a palindrome back. But if there was another CC, you can concatenate it here, and now you have a valid palindrome. See, right? Oh, not exactly valid still. You still need an LL here. My bad. Then you would have a valid palindrome here. So these are the edge cases that we want to handle. So let's see how we can handle that, right? Can I say that if I have LC, right? If I have LC, I would need CL to make it a palindrome. If I have a LC, having another LC is no help, correct? Can I say that if I have a LC and I have some kind of hash map, which says if you have a CL, then you have found a palindrome and you can say that my palindrome counter can go by 4 up, right? You found it, it can go 4 up. So suppose I was on LC first. I say, does CL present in my map? It is not. So all I do is add LC to my map. Remember, adding LC to the map and not CL. Because when we now come to CL, we're going to ask, is LC in the map? It is. So increment my count by plus equal to 4 and also remove LC from the map. And check if the count of LC, that means occurrence frequency of LC is 0, remove it from our map. Cool. So gone. The answer simply now becomes 4 and we return it. Now say we have a GG. LC, first example, CL, GG. We handled till here. What happens to GG? Well, GG would say, is my reverse in the dictionary? It's not. I'll just add it to my dictionary. Dictionary is nothing but hash map. Cool. And you added this. So you did not increment your count here. So you need another one pass through the dictionary now. So in the dictionary, you say if my key value pair, not key value pair, that's what I named my variable, but basically if my word is same, basically, if the word is same, then my count can go, right? My count will go up and then I just break it. So why break? Doesn't make sense, right? Why am I breaking? Well, say you have LC, CL, GG, and then you have ZZ. So I can either make it this CL, ZZ in between, or I can either make it as like GG in between. I really cannot make GG, ZZ, CL. That's not a valid palindrome. That's why we break it. But then a question that might come to your mind is what happens if there's a GG, GG, and CL? Valid, completely valid. Here you can also see valid, 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 valid. What happens? Well, keep in mind in your first for loop, this one, you're handling this case. First time you say GG doesn't exist, add it to the dictionary. Next time this exists in the dictionary, you increment your count to +4. Make a dictionary minus minus this frequency of it, remove it from dictionary if it becomes 0, which we will. So nothing exists in the dictionary, so this for loop is basically not gonna execute, return count 8. This handles all the case. Now I'm gonna talk about space-time complexity. Space-time complexity, very easy to see. Space, definitely O of n. Have a dictionary right there, right? O of n. And then for my time complexity, I am traversing through all the words. So if the length here is n, right, which is generally what we assume it to be, so it's just gonna be O of n. Very cool. This is basically again O of n to pass, but O of n, O of n is just O of n. Cool. Which is pretty basic. So that's how you do this question. Let me know if you have any other questions in mind which you would want a video on. Basically, the trick is to check for the reverse, but add the current if reverse is not present. That's the whole trick to this question. And this one is a little bit tricky, not that tricky part, but this was a little bit tricky. And that would be the whole question. See you guys in the next video.